All right. 5.4. So we have, I think we have a thing of notes. Well, 2 theorems, and then an example, and then 2 corollaries, and then an example, and then that's it. So not too much today. 5.4, equilateral and isosceles triangles. Students will be able to use the base angles theorem. So pretty much everything we're doing today is revolving around the base angle theorem. Students will be able to use isosceles and equilateral triangles. As a reminder, what is an isosceles triangle?
2 sides are the same.
2 sides are the same. Yep. That looks more like, well, 2 sides are the same.
Whoa.
What about an equilateral triangle?
All sides are
All
equal.
sides are equal. Now, if all the sides are equal in a triangle, what does that mean about the angles? That the angles are all equal. Sweet. We already knocked out one of our corollaries today. Good job. So, if a triangle is equilateral, it is also angular.
Good job, Will.
Nice job. That's like one slide of notes that you guys just knocked out in the learning card. Good job.
Slick.
Home run. Who can remember, as a review, what a converse is besides shoes?
Oh.
What is a converse? Or give me an example of 2 sentences that are converse.
Opposite.
Kind of opposite. Alton?
A converse could be like, it's like the same sentence except like worded differently.
Yes. Can you give an example? Because you're on the right track.
It's like having like a shoe. It's like 2 pairs of shoes, and the left one says right, and the right one says left.
Actually, yes. You're on the right track.
Virgil did that.
All right. Keep going with it though. Give me an example.
Freestyle.
It's like wording things differently.
Okay, so I mean you're right. You guys are actually somehow totally on the right track. All right. A converse. So here would be a converse. Okay.
Don't mess up.
If Trey got 105% on his test, then he would be as smart as Mr. Laman. Okay, so there's our sentence. If Trey got 105% on his test, then he would be as smart as Mr. Laman.
Oh, I got it.
The converse of that would be, if Trey was as smart as Mr. Laman, then he would get 105% on his test.
You're just rewording things.
So you're putting your left shoe on your right foot and your right shoe on your left foot, right, Will? Right, Will? Right, Will?
Yes. I'm looking at the right lap.
He actually pulled them up.
You did?
Virgil did that.
Okay. So we'll be dealing with some converses today. You guys did a pretty good job, so I don't even need to go through that extra review slide. Here's where the notes start. So you'll want to get this picture down. Don't write this whole paragraph down unless you really want to.
Wait, you write the picture?
Draw the picture. You do not have to. You could write the picture.
And what am I labeling it?
The things that are labeled on there.
No, like what is like the thing on the note?
Yeah.
Let me see what.
Good job.
Andy sells them to me.
Yeah. That is so you have to be friends.
Let's go. Notes. Enough of whoever our shoes on the wrong feet.
You don't know Virgil.
He's never like this. This just doesn't.
Draw the picture. Label the picture.
What would be the title for these notes?
Funny.
Lesson 5.4. Yep, this is the recording that will go on YouTube.
Can you give me a shout out?
Shout out to Trey Keeson.
Yes. Let's go.
Yep, Zach's in class 2.
Let's go. So am I.
Like and subscribe. Friendly on board. Hit that notification.
No, hit the subscribe. Notifications.
I already said it.
Hit the notification bell. Make sure you never miss out on another one.
Let's go. Get the picture down.
Absolutely destroy the like button, guys. If we
Bro,
get more
absolutely
thousand likes,
destroy it for
we're
new
gonna do another
epic
math time.
content.
So
I don't need it.
I mean, we'll need it eventually.
But I
So,
remember.
when an isosceles triangle, when an isosceles triangle has exactly two congruent sides. So when an isosceles triangle is actually an isosceles triangle, so it follows its rules, two congruent sides. Then those sides, we call them the legs. Kind of makes sense. The legs. The angle that is formed by the legs is called the vertex angle. Vertex angle. The third side is the base of the isosceles triangle. Now, the thing that is easy to mix up is that, say we have an isosceles triangle here, then the base doesn't mean that it's always the bottom or like the furthest down side. Remember, the base is just the one that is not congruent to anything else. The two angles adjacent to the base are called the base angles. Kind of makes sense. We're going to learn something really cool about base angles. Can anyone guess?
They're
different than the vertex angle.
They are different than the vertex angle. I guess you're going to have to just wait for the slide to see. Here are our two theorems for today. Base angle theorem. If two sides of a triangle are congruent, then the angles opposite of them, so the base angles are congruent. Less. So in this case, we have AB and AC are congruent sides. That means angle B is equal to angle C. That is the base angle theorem.
Do I have to write down the words? Or can I just write the
I would
picture?
write down base angle theorem, draw that picture, and then I'd write down that statement at the bottom.
So, everything.
Not the words in the middle.
What? What words in the
No,
middle?
I'm erasing that.
Not that deep.
I mean, you can, but
I was only like halfway.
What words in the middle?
the ones in the yellow box.
Oh, you said I don't have to write those?
Correct.
You need to write down whatever's gonna make it so you remember the base angle theorem.
I'm not going to remember it anyway, so.
They do. I think it's 5 points. You can double check.
If two sides.
Also, whoever shot all these rubber bands can pick them up when we start working and put them back where they're supposed to go. Five, 6, and 5, 7. Oh, I forgot to post it.
Why would you cut the video? Because I'm just going to be sitting here for a long time doing these ones.
The virtual students can just fast forward through it. The second one doesn't make sense.
Two angles of a triangle are congruent on both sides, opposite downward.
Oh,
So with the first one, base angle theorem, like I said, if we have those sides that are congruent, then that means that these angles are congruent. On the other hand, or the converse of that would be, if they tell us that these angles are congruent, that means that the sides also have to be congruent. Okay? So it's kind of the opposite end of the coin. Same idea, just switched around.
So
Or
we got
the converse, as some people might say. Now, this is important because when we're writing our proofs, which we don't have as many proofs today, there's really 2 of them today. But when we're writing our proofs, you need to know if you're using the base angle theorem or the converse of the base angle theorem. And that will be marked either correct or incorrect based on if you use the 30 more seconds.
Hold on, I'm gonna need a minute.
Write the title, draw a picture, and then give the statement at the bottom.
Yeah.
I'll post the slides.
Oh, no.
So you can catch up.
Give me just a slow 30 count.
of a triangle are congruent.
No, no.
These will be posted on Canvas during our
But I'm gonna forget about them. No, wait,
Sides
wait.
opposite them are congruent.
Oh my
Alright,
god.
here's an example. In triangle DEF, very straightforward example.
Quick with it.
DE is congruent to DF. So what would our congruent angles be?
F and E.
F would be congruent to angle E. Good job, everybody. And here are some more notes.
And I knew there's
And these are the last notes.
Okay.
The corollary to the base angle theorem. Remember, remember, a corollary is just like an extension of the theorem. So we're taking that theorem and just building off it a little bit. I would write down the name of these corollaries. You probably don't have to have the picture, but the corollaries just say if a triangle is equilateral, then it is also equiangular, which we talked about in the very beginning. I told you, we already looked at our corollaries in the learning targets. On the other hand, if a triangle is equiangular, then it is also equilateral. So can't have one without the other. This is our last thing in notes, then we have an example, and then you get to practice what we just learned, and then you get to practice it on a worksheet. Yes.
What?
Actually, the worksheet is pretty sweet.
That's what you said last time.
Well, we didn't do a worksheet yesterday. Last time we did a worksheet, what was the last worksheet we did?
Last one.
Yeah,
Yesterday?
so.
Oh, we didn't do big ideas yesterday, did we?
No, we did a worksheet yesterday.
That worksheet was,
is Monday. That was the one we all complained about.
oh yeah, that's why we practiced it again yesterday.
Wait, is it Friday?
Oh my gosh.
The worksheet made a lot much more sense than the big ideas.
I get that.
Much.
I don't think,
I
on
think we're all
Monday,
just off that day. So
I think everyone was off. I don't think I explained it as well as I could have, so that's part of the reason that we took another day.
This game is trash.
Okay.
No.
for that.
Shit, this is not a game.
This is life.
Alright,
Like 1 second. 1 second.
find the values of x and y. So first, if we look at
That's enough.
this triangle, the smaller one here, what do we notice about all the angles? They're all the same. So what does that mean about all the sides?
Equilateral.
That means all the sides are the same too. So what does that mean y has to equal?
Four.
4. Good, so y equals 4.
And x equals 5. Wait, no. X is 4. 3.
Nice. How did you find 3?
X plus 1. X plus 1 equals 4.
That's 1.
Plus 7 is 3 plus 1.
X plus 1 equals 4.
Pete,
So that's,
some people don't know this. Not bad.
how did you know that we could set x plus 1 equals 4 up?
Because all the sides are equal and
Not with that second triangle.
Yeah, what?
There we go.
yeah, what Zach said. You're out getting at.
Listen up here and then you'll get to start in the practice. Since these two angles are congruent, that means that these two sides are also congruent. So that is why we were able to set up x plus 1 equals 4. So x equals 3. Problems like this, not this simple, but problems like this are what we will be looking at in homework today. You have to use all those relationships. Yes. Yeah,
the bottom?
Look like that.
I don't know.
What's the bottom one?
Bottom.
What's the bottom one?
Wait,
Alright, here's the practice. Do the practice, get the worksheet.
Mine's about. Dude, that thing's a Giza. It's a Giza. What the heck?
No, yeah.
Oh, train.
Where's the Kobe logo?